Okay, so I am going to talk now about the second, come on. Okay, the second topic in 1.3 is evaluating the trig functions of 0, 35, 30, 45, 60, and 90 degrees. So what that entails is looking at this chart in your assignment. It looks like this. It got kind of blocked off there, but it's how to evaluate the trig functions of 30, 45, and 60. Now some of them might be 0 and 90, but what it comes down to is this unit circle too, okay, and triangles. So when I have a unit circle, okay, and the unit circle, and I'm going to make this real small so I can get it on there. Okay, the unit circle has a first quadrant here, and the first quadrant of the unit circle is here. And the triangles that we get when we put the 30, 60, 90 triangles on the first quadrant of the unit circle is this 30-degree angle here, okay, and this 45-degree angle there, and this 60-degree angle here. What I'm talking about is this angle here is 45 degrees, and then this angle here is 60 degrees. So we have three triangles, right? We have this 60-degree triangle. We have a 45-degree right triangle. This is the right angle. And we also have a 60-degree angle. So each one of those triangles can be drawn on the first quadrant, in the first quadrant of the unit circle. This right triangle here, and this right triangle here. Okay? So your task in this section is to find the missing boxes. Now, for example, the sine of 30 degrees. Now, we can see that the sine of 30 degrees from the unit circle, here's 30 degrees. The sine of 30 degrees is 1/2, see? And the reason it's 1/2 is because the sine is the y value. Now it's also 1/2 because you see this length here is the square root of 3/2. And this is 1/2, right? Because the y value is 1/2. And since it's the unit circle, this triangle here has a hypotenuse of 1. Okay? So the sine of this angle, which is 30 degrees, is 1/2 over 1, opposite over hypotenuse. Okay, so for this problem 21, it would be the sine of 30 degrees, which is pi over 6, and the function value is 1/2. Okay, because we got the triangle. See, 1/2 is the opposite side, and 1 is the hypotenuse. Okay, so the next problem would be like the cosine of 45 degrees. Radians, that's pi over 4, and you can get that from the unit circle. And the function value is the square root of 2/2. Now, the circle, the triangle, that is a 45-degree triangle, is right here. So you look at it like this. See, this length here is the square root of 2/2. It's the x value. This length here is also square root of 2/2. It's the y value. And then, of course, the hypotenuse is 1. So since the cosine is adjacent over hypotenuse, right, it's going to be the square root of 2/2 over 1, which is the hypotenuse. All right, so the secant, which is the reciprocal of the cosine, we want the secant of pi over 4 for this problem. So that's 45 degrees. Okay, so we can do this a couple different ways, but we can see that the secant and the cosine are reciprocals. We know that. But we can also get it, you know, from the triangle, because the secant of the angle is the reciprocal of the cosine, which is hypotenuse over adjacent, because the cosine is adjacent over hypotenuse. So, all right, well, so let's take a look at the hypotenuse over adjacent for this pi over 4 angle right there. So the hypotenuse is 1, and the adjacent side is the square root of 2 over 2. So, well, what's 1 over the square root of 2 over 2? Well, it's 2 over the square root of 2, which has to be fixed. Square root of 2 over 2. So 2 square root of 2 over 2. Now these cancel. The 2's cancel and end up with square root of 2. Alright, so the tangent now of pi over 3. Now that pi over 3 triangle, is right here, see? Where this length here is 1/2. And this length here is the square root of 3 over 2. Now, just that green triangle, if I took it out, I'd have a right triangle here. I'd have 1 for the hypotenuse. I would have 1/2 for the short leg here, because the x is 1/2, so that means I go over 1/2. And then I would have the square root of 3 over 2 for the longer leg there. And this angle is 60 degrees, or pi over 3. So the question here is the tangent of pi over 3, which is 60 degrees. And the tangent, remember, is opposite over adjacent. TOA, so got TOA. The tangent of the angle is the opposite over adjacent. So like over here, and it's the opposite, which is the square root of 3 over 2, over the adjacent, which is 1/2. So this is equal to the square root of 3. So the tangent of pi over 3, which is also 60 degrees, is the square root of 3. So the big idea about this is there are these 3 triangles. Now, there's also these angles that are on the axis. Mrs. Gross and I just decided they would be called the axis angles. So if the angle is 0, remember that the x value is 1 and the y value is 0. And if the angle is 90 degrees, right here, then x equals 0 and y equals 1. And you can basically find your trig functions with the definitions on the unit circle. The sine of the angle is y, and the cosine of the angle is x, and so on. Okay? So moving on, going back to this table, we sort of fill in the blanks here, try to figure out what's going on. Now, let's take a look at this one where we're given the value, right? The square root of 3 over 3. And we have the cotangent. Okay? So the cotangent of square root of 3 over 3, now that's a little tricky because it could be, it could be 30 degrees. It could be the 60 degrees. Now the 30 degree triangle, or the 30, 60, 90 triangle, this is 1, right? And this is the square root of 3 over 2. And this is 1/2. So the question is the cotangent of what angle is equal to the square root of 3 over 3. Now, I know that the cotangent is opposite over adjacent. Okay, or no, is adjacent over opposite. So the cotangent is the adjacent over the opposite. It's the reciprocal of the tangent. So, and we're looking for the square root of 3 over 3. Right, so we're trying to figure out what that is. So it's either got to be 60 or it's got to be 30. So adjacent for the 30 is the square root of 3 over 2 over 1/2, so times 2. So times 2 over 1. So this is just the square root of 3. So now it's not 30 degrees, it's got to be that 60 degrees. Okay, it's 1/2 over the square root of 3 over 2, which ends up being the square root of 3 over 3. So that has to be 60 degrees, which is pi over 3. So you have to work backwards sometimes when you're given the value to figure that out. Okay? Now on your assignment, you have this table that you have to do, all right, for the 30, 60, 90, 45, 45, 90 triangle. And putting those triangles on the unit circle is a real helpful tool to do that. Okay, it's these 3 triangles on the unit circle that you should think about looking at. Okay, there's the 30, 60, 90. Or there's this 60 degree triangle here. There's the 30 degree triangle there. And lastly, we have the 45, 45, 90 triangle. The blue one there. This angle is 45 degrees or pi over 4. And this length is the square root of 2 over 2. And this length is also square root of 2 over 2. And the length of the hypotenuse is 1. So that should help with part 2 of section 1.3. Now we're going to move on to part 3 and 4, okay? Where part 3, what do we have for part 3? Using the 30, 60, 90 triangles in the quadrant 1 to find the common trig values. Now that's kind of like 2, so I think we can combine these two to get a handle on the 30, 60, 90, 45, 45, 90 triangles. Alright, so I will consider this video part 2 and part 3. And it really involves using the 30, 60, 90 and the 45, 45, 90 triangle. And, of course, remember SOHCAHTOA. The sine is the opposite over hypotenuse. The cosine is the adjacent over hypotenuse. And the tangent is the opposite over adjacent. So can you see those 3 triangles in the first quadrant there? You're going to have to hit those up for this stuff. Okay, so that should take care of parts 2 and 3 for chapter 1, section 3. And we'll be moving on to the trig identities after this video.